So hello friend, welcome back to my channel. So today I'm going to discuss about the revision class, which is basically based on structure and bonding. Actually this topic is basic, you can say base of organic chemistry, and if you know very well about all small thing, then you can learn or easily understood the organic chemistry. Okay, so before I start my lectures, so my request to all of you guys, please subscribe and like the channels and click the bell icon so that you can get easily notification and then upload the video and share with your friends. Okay, so now start. So what is so first I will discuss the hybridization and bond properties. Okay, so what is hybridization and bond properties? Inside this we will first discuss the bond properties. And so what is bond properties? Is bond angle, geometry of molecules, electronegativity, dipole moment, bond strength or bond angle, bond length, bond strength, bond strength or bond energy, and last acidity of hydrocarbons. Okay, so all these things I will discuss one by one. Okay, so first discuss the what is the bond angle. And geometry of molecules. So bond angle is basically based on the geometry of the molecules. Let's you have sp3 hydrocarbons, then bond angle will be 109.5 degree, and if you have sp2 then bond angle will be 1 degree, and sp bond angle is 180 degree. Okay, but the bond angle order will be like this. Okay, increasing order. So for this bond angle, the geometry of the molecule will be tetrahedral, and for this bond angle, geometry of the molecule will be trigonal by trigonal planar. Okay, and for this bond angle, geometry will be linear. So here your for this case 25% as character, and here 33.33% as character, and here 50% as character. Okay, so if we see trends, bond angle increase with increase the means has character, as you can see, whereas character is increasing, bond angle is increasing. So now second, discuss the bond length. What is bond length? So bond length actually the it depends of s orbitals. So since s orbital is nearest to the nucleus than p orbital, s orbital is near to the nucleus than p orbital. Okay, then p orbital, then of the same cell. Okay, so the bond length order of this sp3 hybridization will be more than sp2 than sp. Okay, so this is the order of bond length. Okay, so actually the bond length inversely proportional to percentage of s character. S character, if x character low means low, then bond length will be high. Okay, you see sp3, and you can see from this C triple bond C, C triple double bond C, C double bond C. So here is 50% as character, here is 33% as character, and here is 25%, yes, correct. So bond angle and length is 120, angstrom. Here is 1.34 and area is 1.5. Okay, now move for third, bond strength. So bond strength, we can say bond energy. As we know, the shorter bond is stronger bonds. Shorter bond is stronger bonds. As you can see here, this is very shorter one but strong bond. But you can see here, see, very high bond length, but it is a weaker bond. Okay, so actually the meaning of this statement is this. So here the other of bond strength, sp is greater than sp2, greater than sp3. So actually the bond strength inversely proportional to bond length and proportional to percentage of S character, proportional to the electronegativity. Okay, so these things is a dependent relation with bond strength. Okay, now move to the another things. Another thing point, let's get the fourth, electronegativity. Electronegativity, shortly we denote like this. Okay, actually the bond property is like dipole moment, and inductive effect. Depends on electronegativity of bonded atom. So it means that the dipole moment and inductive effect depends on the electronegativity of bonded atom. So I will give detailed information about this also, dipole moment and inductive effect. So here the inductive electronegativity basically comes from the this dipole moments and inductive effect. Okay, so what is the electronegativity? So electronegativity is when a capacity, if any atom have capacity to attract electrons of a bond is known as electronegativity. Okay, so electronegativity order sp3 is higher than sp2, higher than sp3. So this is the order of electronegativity. Okay, so these are the simpler things you should always keep in your minds. Okay, okay, now we move to the another points. Another point means 5. Acidity, last point of this, not last point. Acidity, acidity of hydrocarbon. Okay, so acidity is depends on the electronegativity atoms, carbon atoms, or any atoms. So it's basically depends on electronegativity it depends on the electronegativity of any atom where where hydrogen is present. Okay, so basically acidity is H plus proportional to the electronegativity of that atom. So it means that acidity basically depends on where your hydrogen is attached, means your hydrogen is where your hydrogen is attached to the which species, which atoms. So that atoms mainly gives the information about the acidity. Okay, so if you see example here, your water molecule, and you have this ammonia, and you have this okay. So electronegativity of this oxygen is higher than nitrogen, higher than carbon. So it depends on this hydrogen will be more acidic than this hydrogen. Okay,
So therefore the acidity of these molecules decrease from left to right. Okay, so this acidity is basically decrease left to right here. Okay, and second point, electronegativity also decrease. Okay, left to right. Okay, now if you consider second example, this is first, second. If you see here also, here, so here percentage of a character is 50, here is 33.33, here is 25, but pk value is, which denote acidity, is 25, 44 and 50. So here your S character is decreasing from left to right, and acidity is basically proportional to the Ka value. Okay, so Ka value. Okay, so Ka value means here your pK value is higher, so acidity will be lower for this case, and acidity will be high for this case, because percentage of S character is high for this case. Okay, right, and this is inversely proportional to pK, and this pK actually is equal to the minus log of K. Okay, now move to the last point of this means bond properties. So last is 6 dipole moments. Which is basically it is just denoted mu. Okay, so what is dipole moment? When two atoms, let's H and Cl, when two atoms of different electronegativity, here for chlorine is different and hydrogen is different electronegativity, are joined by a covalent bond. These joined at covalent bond by sharing single electrons. Which is more electronegative attracts to the shared electron pair towards itself. So electron will pull this side. Okay, so electron will withdraw from hydrogen to chlorine itself. So direction of this electron pulling is this. Okay, so this is actually dipole moment, actually the vector quantity. Okay, so and that's why direction is indicated by the arrow parallel to the covalent bond. Okay, and pointing towards the negative ends. Okay, so here Q, this dipole moment is basically Q into L, where as I told you, mu is the dipole moment, q is the charge in ESU unit, okay, and L is the bond distance in angstrom, and unit is dB, okay. Since 1 dB is equal to 10 to power minus 8 ESU, okay, right. Now we see the examples, then we can easily understood, okay. If we see this example, carbon tetrachloride, actually this is this has zero dipole moments, because if you see carbon Cl and Cl, so electronegativity this direction, electronegativity here this direction, so net dipole moment for this is 0, okay. And similarly we can say different another examples like CCl, Cl and Cl. Here will be not 0, here will be the 8.7 dB, because the electronegativity for hydrogen is like this, for this, okay. So that's why the dipole moment is 1.87, and for this case all others attaching ligands are means chlorine or electronegativity same, that's why the net dipole moment 0, but here is 2 is same side and 1 is hydrogen and 1 is different side, so that's why the dipole moment is 1 point. Now you see the this cis 1,2 dichloroethene, okay. So here this, okay. So for this dipole moment is 1 dB. Similarly for trans, okay, dipole moment is 0, okay, dB, because both are creating half dipole moments, that's why both are effectively cancelled out to each other, that's why dipole moments is 0. Now we move to the very important things, which is most of the reactions and other things, the mechanisms all are used. So we discuss the inductive effect. So inductive effect, which is denoted capital I, okay. So what is inductive effect? So it is basically the electron displacements, electron displacement. It is basically electron displacement along HN of atoms, okay. due to the presence of polar bond. Okay, and these whole things is known as inductive effect. And second point, this rapidly decrease as when distance of when a distance from source x decreases. It means that inductive effect effectively decrease when any functional group going away from the other functional group. Okay, so inductive effect will decrease. So this is not valid for non-polar. Okay, because non-polar having same electronegative atom like S2 and Cl2, so this is not valid for this inductive effect, because both atoms have electronegative RCM. It is valid for polar covalent bond. Okay, like this partial charge. So now we will discuss types. It is basically the two types. One is minus I effect, other is plus I effect. Okay, so minus I effect, when any atoms or group which attracts electrons more strongly than hydrogen is known as minus effect, like this R3 greater than NO2 greater than SO2R greater than Cn greater than COOH greater than F greater than Cl greater than Br greater than I greater than OAR. Okay, etc etc. Okay, there are several, but plus I effect, when any atoms or group which attracts electron less strongly than hydrogen is known as plus I effect, like O minus, C O minus, CR3, CHR2, CS2R, CS3. So basically here plus I effect is you can say the donate the electrons to the other species, but minus I effect, electron withdraw from an X species. You can say like that. Okay, So now we discuss the application of this inductive effects. Okay, so we will discuss the application of inductive effect. Where is the use of this inductive effect? That is application. So application first, if the magnitude positive charge okay, like this, and you have group G where G may be the plus I or minus I. Okay, so if we consider the case 1, for case 1, if we took G plus I, then what will be the meaning? So CS2 plus G plus I means it will donate electron. So what will happen if this is plus I effect? So this group donate to electron to this species. So what will happen? The positive charge of this species will decrease. Okay, it means magnitudes of positive charge will decrease. Means here that efficiency of electron will remove, you can say anyway. Okay, and for case second, if you have choose minus I effect, then what will happen? Your electron will your this group will pull the electron. Okay, so what will happen here? Positive charge will increase, but here positive charge will decrease, here positive charge will increase. Okay, so this is the application. Therefore the magnitude of this positive charge will be increased. So if we write the dependent relation, so dependent relation means magnitude of positive charge is depend on minus I and plus I effect, but depends on minus I and plus I. Okay, now move to the second application. When your magnitude is negative charge, so what will happen? So your dependent relation will come out, means magnitude of negative charge will inversely proportional to the minus I power of the group. Okay, so this is the second application of your inductive effect. Okay, that hopefully you understood, guys, what I teach you today. So in next lecture I will discuss the our syllabus CSI and NetGate syllabus topics, which is organic reactivity intermediate. So next lecture I will take about organic organic reactive intermediate. Inside this I will discuss like generation, stability and reactivity of carbocation, carboanion, free radical, carbene, benzene and last nitrogen. Okay, so thank you, good night, bye bye, and please subscribe the channel and like. If you have any doubt, don't please comments. Okay, write your comments. Okay, thank you, bye bye.